are discussing what do we mean by residue. Residue means the insoluble part remaining on the filter paper after the filtration is done. And what is filtrate? The liquid collected in plated container after filtration is the filtrate. Okay? Now we come to what do I mean by saturated solution. Saturated solution. Saturated solution means that no amount of further solvent can dissolve into it. It's fully saturated. We cannot dissolve any quantity of solid in it. Now we come to fractional crystallization. What do I mean by fractional crystallization? Fractional crystallization means a process of separating the components of the mixture of two or more solids having different solubility at the same solvent at the time temperature. The stepwise crystallization is known as fractional crystallization. This is the meaning of fractional crystallization. Now we will discuss the principle of fractional crystallization. Principle of fractional crystallization says that it's based on the difference in solubility. The difference in solubility of two or more substances of the same solvent. The most soluble substance crystallizes first and least soluble substance crystallizes last. Now in a solution of salt and sugar, salt plus sugar, right? In a solution of salt plus sugar, which will crystalline first, this will remain till last, this will crystalline first. So sugar and salt fractional crystallization you have now followed it. Now we come to another method for the crystallization of glucose and fructose from their mixture. I want to separate these two mixtures. What is glucose and what is fructose? Glucose is a material which you take to get energy, and fructose is also a part of it. It is another isomer. So glucose is less soluble in ethyl alcohol, and fructose, so it is separated by the fractional crystallization. The mixture is heated with 90% ethyl alcohol below the boiling point of the alcohol. The mixture, the solution is now cooled slowly, and you get crystals of pure glucose are added to the solution and seed crystal to increase the rate of crystallization. Glucose being less soluble crystallizes outward, leaving fructose in the solution. Crystals of glucose are filtered and purified for the recrystallization. The mother liquor is concentrated by heating. It is allowed to cool down. Slowly when fructose crystallizes out, which is filtered and purified by recrystallization. Both the companies can be separated in a pure form. The pure form of you get in the market is glucose D, which is made by Glaxo. Glucose is the food, sugar is the food of brain, so and the liver. So when you eat glucose D, you get lot of energy to do more work efficiently. Now we will discuss about distillation. The distillation, what do I mean by distillation? The process in which liquid is converted into vapor phase at its boiling point, and the vapor then condenses back to liquid on cooling is known as distillation. So when we do distillation, it involves what? Distillation involves evaporation of liquid and condensation of its vapor. A distillation flask with the liquid is to be purified and fitted with a Lerping water condenser and a thermometer and a is gently heated on a water bath or sand bath. On heating, the temperature rises and boiling point it remains steady till all the liquid is boils off. The vapor of the liquid passes through the side tube of the condenser and that contains the pure liquid called distillate, and it is collected receiving the leaving the impurities of the flask. In the laboratory, we have got a distillation apparatus. There is a given flask, it is called distillation flask, above which we have kept thermometer before and it is also attached with we are pouring impure liquid into it on the tripartite stain. So on this Lepin water condenser, there are two types. One will distillate first, another will pure liquid will collected into the conical flask, right? So these are where the distillation is done, and the thermometer increase the temperature. Now next point which I am going to discuss with you is that how can we separate the components of the liquid mixture containing acetone and water. What is the boiling point of water? The boiling point of water is 100 degrees centigrade and boiling point of acetone is 56 degrees centigrade. So we have to now we have to undergo this distillation in this apparatus so that we get both water and acetone. Now to separate the components of the liquid mixture containing acetone and water, apparatus as shown in the figure above, it contains distillation flask, the mixture of acetone and water, right? Acetone and water are the two miscible liquids which are having a wide difference in their boiling point. Acetone boils at 56 degrees centigrade, the boiling point of water is 100. When this mixture of acetone and water is heated, the temperature of the mixture is 56 degrees and acetone will come out from here. It will come out. Then remaining mixture, when all the acetone comes out at 56 degrees, acetone will be distilled off. When all the acetone distilled off, when the temperature rises to 100 degrees, whole water will also be collected, because the principle used here is different temperature we can distill two liquid which are highly miscible, right? Now the procedure also I will tell you. Take the mixture of water and acetone in a distillation flask and arrange the apparatus. Heat the flask of the water bath carefully and then heat the flask of water bath carefully at 56 degrees centigrade. Acetone will come out from there to distillate. It will be distilled out. Collect it in receiver number 1, and after all acetone is distilled. Change the receiver, discard the few ml of liquid. At the temperature which is 100 degrees, water will begin to distill. Collect this in receiver number 2. So now supposing what will happen if the upper outlet as a condenser is connected to the tap inside of the lower outlet. The role of the condenser is to absorb the heat from the vapors and to condense it and to cool and it forms liquid pipe. A condenser must be filled with full water for this purpose. If the water enters from the top and drains from the bottom, it never fills up. Okay, so this is a precaution while doing this test and performance of this experiment. Now we come to what you are mean by fractional distillation. Fractional distillation means the process of separating and purifying the compounds of mixture having two or more miscible liquids. Miscible means they are highly soluble. They are not insoluble. Okay? Having a distillations different boiling point. This is also known as fractional distillation. The principle, the liquid which is more volatile distill out for leaving behind the less volatile liquid in the distillation flask. Fractional distillation using the fractional column. Now here, when the difference in boiling point of the two miscible liquid is less than 30 K, because it is separate form can never be pure. Therefore, fractionating column is is inserted between the flask and the condenser. The column consists of as shown in the figure. It has got thermometer at the and a fractional column liquid which will be distilled. Then we have got a Analytical water condenser and a receiver. So the column consists of number of obstruction due to which the cooling areas for the hot vapors increases. When the vapor or the liquid rise in column, they come into the contact with large areas of obstruction. This is large areas of obstruction as shown in the figure. Vapors of the liquid having the lower boiling point rise up and column of the pass over this condenser, and then we have got whereas the vapor of the liquid having higher boiling point are contains the column itself. They are contains here in the column itself. So liquid or vapor of higher boiling point here contains the column itself and contains the liquid trickles down back into the distillation flask. This automatically separates the fraction of the two liquids. This is called fractional distillation. Okay, now I am going further. Fractionating column provides many surfaces for the heat ascending vapors and descending condensed liquid. We have got many types of fractionating columns and cross columns and are available in various shapes and design. Okay. First is younger pear-shaped column. It is younger pear-shaped column. I am showing you in the figure. The next is Henkel's column. The third is simple packed column and bubble plate column. Now I would like to suggest what is the difference between simple distillation and fractional distillation. Simple distillation is used for Thank you now. So now we will discuss what is the difference between simple distillation and fractional distillation. Simple distillation is used for the separating of the liquids having sufficient difference in their boiling point. Fractional distillation is used to separate the mixture of one or two miscible liquids which have their boiling point close to each other. Now we come to the topic distillation under reduced pressure. Now this is also a very important topic. Distillation, liquids which are having very high boiling point or those which decompose on heating are purified by carrying out distillation under reduced pressure. In this method, the liquid is made to boil at a temperature which is below the normal boiling point by reducing the pressure on the surface of the liquid. The pressure is reduced using a water pump or vacuum pump. In soap industry, the glycerol is separated from force. See, this is a diagram, right? Got stop drop, capillary to regulate, then glass funnels to sink, then distillation liquid comes here. There is a vacuum paint, there is a manometer here, capillary to regulate the air. This is called distillation under reduced pressure. Now we can also explain how the solvent extraction takes place. Now why we need solvent extraction? Because the edible oil which we are using and consuming, there it is used. The method to separate the two liquids at a different boiling points. Now most of the organic solvents like benzene, chloroform, petroleum, ether are immiscible with water. Such solvents are used to extract an organic compound present in aqueous solution by the method of a different extraction. The aqueous solution containing the organic compound is transferred to a separatory funnel. This solvent, in which organic compound is more soluble than water, is then added to the aqueous solution. The separatory funnel is shaken vigorously so that aqueous solution and the organic solvent mix thoroughly well and emulsion is formed. The mixture is then allowed to settle Till the two distinct layers are seen, the organic layer is separated and the organic compound is recovered from it either by evaporating the organic liquid or subjecting it to distillation. These are the two solvent extraction process. First is solvent layer, organic compound in aqueous layer. Then we have got organic compound in solvent layer, and aqueous layer is down here. If the solid is less soluble in organic phase, that time we use this method. A technique is also called continuous extraction and is used where the some amount of organic liquid, organic solvent is used repeatedly for the extraction. The technique involves continuously distillation of the solvent, the same assembly. This use of large quantity of the organic solvent is added. Now any edible oil is manufactured by this process only. For example, Patanjali oil is also manufactured by this process. We want to separate solvent extraction plants which are very costly these days, and the edible oil which you are getting is separated from impure level to pure level by this method only. Now, organic solvent used for the solvent extraction should be immiscible with water so that the organic layer and aqueous layer can be easily separated. Now the question comes to mind, what do I mean by solvent extraction? Solvent extraction is a method used to separate organic compound in aqueous solution into an organic solvent in which it is more soluble by shaking it to separating one. Now, what do I mean by distillation? Distillation is a method used for the purification of liquid which boils with decomposition and certain non-volatile impurities. Non-volatile impurities, I mean, which cannot go out even after heating the liquid. Now we come to the very important technique, chromatography. For any medicine we manufacture in the pharmaceutical plant, all the raw materials are first passed through this chromatographic technique, and then only they are passed for the process of production of these medicines. Even corona vaccine will be done by the same procedure. So chromatography is an important technique extensively used to separate the mixture into their components, to purify the compounds and also test the purity of the compound. The name chromatography is derived from the Greek word chroma, meaning color. Since the method was used for the separation of the colored substance found in the plants, in this technique the mixture of the substance is applied on stationary phase. It can be solid or liquid. A pure solvent, a mixture of solvent or a gas is allowed to move slowly over the stationary phase. The compounds of the mixture get gradually separated from one another. The moving phase is called mobile phase and another phase is called stationary phase. These are two classification of the chromatography: absorption chromatography and partition chromatography. Now, if anybody will ask me, what do I mean by stationary phase? Stationary phase is the one that remains in the fixed column of the chromatography. Right? On the basis of the stationary phase used, chromatography is classified into absorption chromatography, partition chromatography. Absorption chromatography is based on a principle of differential adsorption. It is classified into two types: column chromatography. It involves the separation of the components over the column of the stationary phase. Thin layer chromatography. Thin layer chromatography, it involves thin layer of the absorbent silica or aluminum over the glass plate. Now we come to partition chromatography. Partition chromatography is a stationary phase and mobile phase. Both are liquids. Now we come to adsorption chromatography. Adsorption chromatography is based on fact that different compounds are absorbed on an adsorbent for different extent on the stationary phase. Commonly used adsorption are silica gel and alumina. When the mobile fluid is allowed to move over the stationary phase, adsorption of the component of mixture move away from varying distance over the stationary phase. Following two main types of chromatographic techniques, which is based on principle of differential adsorption, that is called column chromatography and thin layer chromatography. So we will revise up till now what we have studied in the points form, which will help you during the examination. Right? Basic analytical techniques are used for the analysis of the chemical substances. Method of purification and compound depend on difference of the physical properties. Now, purification of the solid. A solid may contain two types of impurities. One is soluble in the same solvent or insoluble in the same solvent. Right? Insoluble impurities are separated by the filtration. When the filtration is carried out using a vacuum pump, it is called filtration under suction. Bushner funnel is fitted with a conical flask on the rubber prop. Now we come to crystallization. I am revising crystallization again for you. The process of obtaining solid in pure and crystalline form its solution is known as crystallization. The process includes the separation of solution, hot filtration, cooling of the filtrate and fractional is followed by drying and cooling of crystal. Fractional crystallization. It is based on difference in solubilities of the two soluble substances. Two soluble solutes are added with a hot solvent to form saturated solution, which on filtration, cooling, washing with a solvent and drying form pure substance called crystals. Now we come to distillation. In this process, the difference in solubilities of the solvents of the two soluble substances is what discussed with you. The process includes preparation of the saturated solution, hot filtration, cooling of the filtrate, and the filtration followed by drying and cooling of the crystal. Distillation. It is for the liquids having different types of boiling point. Now what is boiling point? Boiling point is a question is asked in 12th standard, 11th standard and everywhere. Boiling point means the temperature at which liquid boils to form vapor at 1 atmosphere pressure. So that is the boiling point. Okay? So now we are telling you, it is for the liquid. Distillation is used for the liquids having large difference in their boiling point. It is used to separate volatile liquid from non-volatile impurities. It is of two types. Simple distillation, it is used for liquids which boil without atmospheric decomposition. Fractional distillation, it is used for the liquids with less difference in boiling points. Now, as I explained you, we discussed about acetone and water. Now I am telling you, we also discussed about distillation under reduced pressure. It is used for the liquids with high boiling points which decompose on heating and are purified by the process under reduced pressure. Solvent extraction. It is a technique based on difference in solubilities of the organic compound, organic substance in two phases. The organic liquid should be immiscible with water and form two layers. If the solid is less soluble in organic phase, it is called continuous extraction process. It helps in clean separation in a very short time. So, and I told you example also, Patanjali doing solvent extraction, any edible oil manufacturer, they are doing solvent extraction process only. There were so many edible oil manufacturers, whichever edible oil you consume at that time, you think of solvent extraction process. It is manufactured by solvent extraction process. Then we discuss also about chromatographic techniques. It is a technique used to separate components of mixture based on eluting power and to purify the compounds. It has two phases, stationary phase and mobile phase. Absorption chromatography is based on the principle of differential absorption. Column chromatography, it has two phases, stationary phase and a mobile phase. Mixture is dissolved in small amount of solvent and loaded on the top of the absorbed column, fractionating column. Most strongly absorbed component is retained on the column and other moved on forming the bags. The components which has less strongly absorbed in different described in first part. Thin layer chromatography, it is also called TLC. Or I will make you again revise for you. It is used for the pharma industry and you have to be very whatever medicines we manufacture, they have to be 99.9% pure. If the medicine is not pure, the patients will die. Now always COVID vaccine which is manufactured also made by TLC chromatography first and then undergoing the process. The stationary phase in silica gel and alumina over a glass phase. The mobile phase rises up the component of the mixture, move different distance depending upon the degree of absorption and gets separated. If the components are colored, they appear as the colored spots on the plate. If the components are not colored, they can be visualized by UV light. What is UV light? UV light is ultraviolet light. On a plate is kept in chamber with iodine to give brown color. You must remember this important formula, retention factor. RF. RF is distance traveled by the solute from the baseline divided upon distance traveled by the solvent from the baseline. Therefore, to sum up my lecture, chemical substances occur in nature in pure form and when synthesized in the laboratory, they are obtained in crude and petroleum form. Difference in physical properties like boiling point, density is used to purify and separate the chemical compound. Even our petrol is also done by the extraction plant. A big extraction plant is set up. They will distillate the different liquids at different temperature and you will get in the form of petrol, diesel, naphtha is the starting material and other products also. So again I will make a revision for you. Crystallization, the process of obtaining a solid in a pure form and crystalline form from its solution is known as crystallization. It is based on the difference in solubility of the compound and the impurities in the. Thank you very much for attending my lecture very seriously. I hope you have all followed everything. In case of any doubt, you can again ask me and free to ask me anytime. Thank you, sir. Thank you.